The third unit of concentration that we're going to learn about is molality. Molality is the number of moles of solute per kilograms of solvent. We represent it with a lowercase m. Please make sure that you distinguish that from the uppercase M of molarity. The way we can do that for molarity, make sure your M's are capital and pointy. You can also underline your M for your molarity to show that it is capitalized. So problem 1, what is the molality of a solution that contains 80 grams of aluminum sulfate and 625 grams of water? To break this problem down, we will have 4 steps. Step 1 will be to convert grams of solute to moles. Our solute is aluminum sulfate. Step 2, we're going to convert grams of our solvent to kilograms, and our solvent is water. In step 3, we're going to plug it into the formula, and step 4, we're going to solve and round to appropriate significant figures. So we have 80 grams of aluminum sulfate that we must convert to moles. Since we want moles, they're going to go on top. So 1 mole of aluminum sulfate has how many grams? And we add that up in the periodic table. We have 2 aluminums, plus we have 3 sulfurs, plus we have 12 oxygens. Please make sure that you distribute your 3 inside the parentheses. And so we get that the molar mass of aluminum sulfate is 342.14. To find the number of moles, we're going to divide. 80 divided by 342.14. And we get 0.233. And the reason why I'm keeping 3 significant figures is because in the problem we were given 80.0, which is 3 significant figures. Next, we're going to convert our grams of water to kilograms. We know that the conversion for kilograms and grams is 1 kilogram is equal to 1,000 grams. So we're going to divide by 1,000, and that will give us 0.625 kilograms. At this point, I would expect that you already know how to do this conversion and you could do it in your head. So you do not have to show the work for that step. You do, however, have to show your work to convert grams to moles so that I can make sure that you have the right molar mass. Alright, then our next step is going to be plugged into our formula. So the molality is equal to the moles of solute, which was 0.233, divided by the kilograms of solvent, which was 0.625. And then we solve and round to the correct significant figures. So 0.233 divided by 0.625 is 0.373. And that has a little m, or you could write moles per kilogram. Either a lowercase m or moles per kilogram would be an appropriate unit. The reason why we kept 3 significant figures is because both 80.0 and 625 had 3 significant figures. So your answer must have 3 significant figures. Problem 2. What mass of water is required to dissolve 175 grams of potassium nitrate to produce a 2.25 mole solution? To solve this problem, we're going to first convert grams of solute to moles, and then we'll plug into our formula and solve. Here we're going to need some algebra. So we have 175 grams of potassium nitrate. We're going to convert that to moles. So 1 mole of potassium nitrate has how many grams? So we have 1 potassium, 1 nitrogen, and 3 oxygens. And we get 101.1 grams. And so since our 101.1 is on the bottom, we're going to divide 175 divided by 101.1, and we get 1.73 moles. Again, I'm keeping 3 significant figures because I was given 3 significant figures in the problem. So next we want to plug into our formula. We know the molality this time is 2.25. That's going to be equal to moles of our solute, 1.73, then divided by kilograms of our solvent, which we don't know. Now here's where algebra comes in. We're going to have to solve for x. So the first thing you're going to want to do is cross multiply. And so you get 2.25x equals 1.73. And then x is going to be equal to 1.73 divided by 2.25. And we get 0.769. Again, I'm keeping 3 significant figures because that's the number of significant figures that's given in both the numbers in the problem. And since we were looking for the x's on the bottom, the mass of the water, remember in molality, that unit is kilograms. So our answer is 0.769 kilograms. Now you have some time to practice. Pause the video and begin the problems on your worksheet. The answers to the 3 problems on the worksheet are 0.500 mol/al, 4.00 mol/al, and 1.14 kilograms. If you got these correct, you can stop the video now. If you did not, then please continue watching as I solve the problems for you. Number 1, we have 63 grams of HNO3 and a 0.500 grams of water. So our first step is going to be convert our solute to moles. And so 1 mole of HNO3 has mass of 63.018. And so when we divide that, we get 1.00 moles of HNO3. Again, I'm giving 3 significant figures because I started with 3 in the problem. Next, we can plug into our formula. The molality is equal to the number of moles, 1.00, divided by the number of kilograms of solvent, 0.500. And so when we then divide, we get 0.500 little m, or 0.500 moles per kilogram. And again, we're keeping 3 significant figures because we were given 3 in the problem to begin with. So that's number 1. Number 2, we're given 0.5 moles of HC2H3O2, and it's dissolved in 0.125 kilograms of water. What is the molality? Here, no conversions were required because we were given in the units that are molality. Moles per kilogram. And so then we divide 0.5 by 0.125 and we get 4. Now, because we were given 3 significant figures in the problem, we must report our answer to 3. So 4.00 little m, mol/al. Number 3, We add 100 grams of sodium chloride, which was used to make a 1.5 mol solution. We want to know how much water. So our first step is to convert our grams into moles for our solute. So 1 mole of sodium chloride, that's 58.44 grams. And so then we divide 100 by 58.44, and we get 1.711 moles. Now I kept 4 significant figures here because I was given 4 in the problem. So next I'm going to plug in what I know to the formula. We have 1.50 as our molality, and that's equal to 1.711 moles over the amount of water, X. Again, I'm going to cross multiply, and you get 1.50x equals 1.711. So then our X is going to be equal to 1.711 divided by 1.5. And we get 1.14. And that, since we were looking for our X was in the bottom, we're looking for the amount of water, that's in kilograms.